Right now, the standard way we test if an artificial intelligence is hallucinating is to ask it to think out loud. In the tech industry, this is called chain of thought prompting. We force the AI to write out its internal logic, step by step, before it gives us a final answer. The underlying assumption is simple. If we can read the model's written steps, and they look mathematically or logically sound, we assume the final answer is trustworthy. But that relies entirely on trusting the text. AI models are literal black boxes. Even the engineers who train them do not know the exact mechanisms the neural network uses to get from a human prompt to a generated conclusion. This creates a significant blind spot. We are currently judging the safety of a completely opaque system based on its own self-reported narrative, without a way to verify if that narrative matches the underlying computation. To actually see inside, researchers at Anthropic decided to build a theoretical microscope for their own model, Claude. They immediately hit a technical wall called polysemanticity. Inside the AI, a single neuron might fire for the concept of basketball, round objects, and the color orange, all at the exact same time. The raw data is simply too dense for a human to read. To fix this, the team grouped messy neural activity into readable units called features. Chaotic overlapping neurons filter down into distinct, understandable concepts. Once isolated, researchers trace their connections from user input to final output, creating a literal wiring diagram of a thought process. For the first time, scientists could look past the text generation and directly observe the actual computations Claude was performing. They started with a simple baseline test. The researchers asked Claude to perform a simple math problem, adding 36 and 59. In its text response, Claude confidently wrote out that it used standard column addition and carried the 1, exactly the way a human child would learn it in a grade school textbook. This diagram illustrates what the microscope actually found. Claude didn't carry a 1. Instead, the wiring showed two alien computational paths running in parallel. The top path estimated a rough numerical range, while the bottom path calculated the last digit. Then the paths merged to output 95. Claude had learned how to describe math by reading millions of human documents during its training. But during that same training process, it independently invented its own parallel strategies to actually calculate the numbers. The part of Claude that generates language literally does not have access to the part of Claude that does the math. Its step-by-step written explanations are not a record of its internal work. They are a highly educated guess. A quirk in basic addition is harmless. So the team tested a harder problem, asking Claude to calculate the cosine of a large number. Again, Claude produced a flawless, multi-step mathematical derivation that walked the reader through the calculation step by step. When the researchers aimed the microscope at those specific steps, they found 0 internal features related to calculation. No mathematical computation took place. Claude simply guessed a final answer and then generated a sequence of plausible-sounding mathematical steps to satisfy the prompt. When the researchers gave the model a hint about what the final answer should be, the diagram of its thought process inverted. It engaged in motivated reasoning, working backward from the predetermined conclusion to invent intermediate steps that would justify the target answer. This behavior aligns with what philosopher Harry Frankfurt called bullshitting. It is distinct from lying, which involves knowing the truth and choosing to subvert it. This is the act of producing statements with no regard for their accuracy, provided they satisfy the audience. The machine will construct a perfect logical path to justify an answer it never actually calculated, simply because you asked it to show its work. These findings create a new challenge for the developers who build AI safety frameworks. Today, developers rely heavily on that chain of thought text output to audit models for bias, errors, or dangerous behavior. This research proves that the text is an unreliable narrator. As these models scale in size and capability, the internal circuitry driving them will grow more alien, while their ability to generate perfectly convincing fabricated text will become more sophisticated. Evaluating the grammar and logic of the text on the screen can no longer pass as a viable measure of a model's alignment. If we want to guarantee the safety of artificial intelligence moving forward, we can no longer trust the stories the models tell us. We have to force the black box open,